Good afternoon, everyone, and thank you, Dr. Liu, for introducing me. And I'd like to thank also my professor Lavecchia from Milan and Dr. Augustin for giving me the opportunity to present here today. I will show the update on the development of the dietary glycemic index and low database in countries of the Mediterranean region. As Dr. Liu introduced, this project is part of a global glycemic index consortium that is a program designed to systematically curate and analyze dietary glycemic index and glycemic load data from representative national dietary surveys and cohorts, with the main goal to develop a unified and standardized global dietary GI and GL database by assigning appropriate GI values to carbohydrates foods across region, and then link this data with mortality and disease burden to evaluate the role of carbohydrate quality. The consortium aims to involve countries and researchers from all over the world, and in particularly I'm focusing on Mediterranean region. We choose this region because it's here that the Mediterranean diet take its origin, and we know that this healthful dietary pattern is characterized by a high intake of carbohydrate-rich food, moderate intake of total fat, and a low consumption of saturated fat and sugar. However, the quality of carbohydrate intake measured by the glycemic index has not been systematically assessed in countries of this region. And we know that many traditional foods, like pasta, bread, have a low glycemic index and glycemic load if compared to non-Mediterranean equivalents. And also the quality of carbohydrate-rich food also differs between Mediterranean countries for different recipes, different methods of cooking, and go on. We know that the glycemic index and glycemic load are measured to evaluate the impact of carbohydrate-rich food on blood glucose. And from literature, high values of dietary GI and GL have been associated to a high risk of type 2 diabetes, cardiovascular disease, certain cancers, weight gain, alteration in lipid profile, and other cardiometabolic risk factors. For this reason, the aim is to develop a comprehensive dietary GI and GL database for selected European countries in Mediterranean region. Firstly, identifying nationally representative dietary surveys from these countries, and then linking food consumption data from this survey with GI reference databases, and then estimate the dietary GI and GL for each country. For the data collection, we identified the European Food Safety Authority dietary surveys. This authority, in fact, coordinates national dietary surveys across European member states to collect harmonized and high-quality food consumption data. These dietary surveys are methodologically harmonized, so the sample are representative, and the dietary assessment to collect foods and beverage consumed are at least to 24 hours dietary records. For this reason, I submitted a formal request to EFSA to obtain individual level data from specific dietary surveys of interest, plus the request of food consumption data and several covariates. So far, we have obtained from EFSA 7 out of 9 dietary surveys requested, from which we are still waiting a response from Cyprus, and the data providers from Greece denied to participate with us. Here briefly the details of the dietary data obtained. So far, we have two dietary surveys from Italy, one from Portugal, Spain, Montenegro, Croatia, and France. Dietary survey pretty recent that range between 2014 to 2023 with a number of subjects between 1,000 to 5,000 for Portugal and France, with a number of food collected between 1,000 to 3,000. The first step was the understanding the food classification system, because EFSA used a food coding system called the FoodX2. So for each food collected, we have a food code. And for each food code, we have a food description. For this reason, we decided to extract only the simple description of the food collected. We extracted like 1 million of simple descriptions. And since these simple descriptions were not unique, we grouped the same one to obtain a unique list of food items, like 2,000, selecting only the food with a content of available carbohydrates above 5 grams, to continue with the assignment of the GA values. For the assignment, we used all the source available in literature, so the International Glycemic Index Table, the database from the University of Sydney, and the database of Diogenesis, and all the published and unpublished GA values. And the first step was the automatic matching. So we used an AI-enabled model to match the EFSA simple description with the GI values from these sources based on the text similarity. Right now, the manual verification is still in progress. And here I'll show you some example of this verification. In the first line, you can see that the match is perfect, so there is no need to change the value. But for example, in the second line, we can see that mayonnaise low fat was matched with buttermilk low fat only for text similarity. So here is important to correct the match, and I put 0 because mayonnaise is a food without carbohydrate content. Another example is when for a single food item we have multiple entries. In this case, wet bread and rolls, we have a lot of GA values. So it's important to do an average of all GA values. Another example is when we have a mixed meal. So it's important here weighted GA values for all the ingredients of the meal. And another example of the correction of GI is when a food has not been tested, like medlars. So in this case, we assign glycemic index based on a similar food type, so, or a food of the same groups. The next step will be the calculation of dietary glycemic index and the glycemic load for each participant. And basically, the dietary glycemic load for each participant is the sum for all food consumed, the product between the glycemic index and the available carbohydrates content divided 100. And then we can obtain the dietary glycemic index, that is basically the dietary glycemic load divided by the total daily available carbohydrates. So the next step will be continue to with the manual verification and completion of GI assignment, search for missing GI data from gray literature and unpublished data, identify some gaps, so food with a high carbohydrate content, with a high contribution in the diet, but not locally tested or with existing similar GA values. Then identify the top 20 carbohydrate-rich food per each country, and then the estimation of dietary glycemic index and glycemic load at population and subgroup levels for each country. In the end, we are open to collaboration, so the sharing of national dietary surveys from other Mediterranean countries is welcomed to support the development of this database, and thank you all for your attention.